All right, friends, good morning. We are starting our math lesson. We're going to review today for Unit 6. So please stand up with me. Let's warm up with our factor finger. Good job. All right, let's stretch them, flex them, and we're only going to do about 3. Squeeze them, shake them, tap them, and massage them. All right. Anybody want to lead us? Let's do 6s, 7s, and 8s. Who will lead us in 6s? Loud and proud. Tia, thank you. Here we go.
6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72.
6 times 1 is 6.
6 times 2 is 12.
6 times 3 is 18. 6 times 4 is 24. And 6 times 5 is 30. 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. 6 times 9 is 54. And 6 times 10 is
60. 6 times 11 is 66. And 6 times 12 is 72.
Good job. Who would like to start us with 7s, the happy facts? Elias, go.
7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84.
7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. 7 times 6 is 42. 7 times 7 is 49. 7 times 8 is 56. 7 times 9 is 7 times 10 is 70. 7 times 11 is 77. And 7 times 12 is 84. All right, good. And who will do 8? Those are the ones that we are struggling to remember all the time. Henry, let's go. Ready? 8.
8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, 96. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. 8 times 6 is 48. 8 times 7 is 56. 8 times 8 is 64. 8 times 9 is 72. 8 times 10 is 80. 8 times 11 is 88. And 8 times 12 is 96. Good job. You may be seated. Excellent. All right. We just discussed that we are having our Unit 6 test on Friday. We need to review, okay? Up here, we are going to do a series of reminders. We're going to read our objectives. That means what was our mission for this entire unit. After that, we're going to do an example of each. So I need to make sure that you have all of your math tools ready. Please raise your hand or raise up the math tool that you're going to use to be successful today. Good. I see whiteboards. I see area model templates, markers. Do you have a pencil as well? Wonderful. Okay, you may put that down and let's get started. All right, who can read our first objective? This is where we all started in lesson 6-1 through lesson 6-3. All right, Elias, loud and proud.
I will multiply a one-digit whole number by a multiple of 10 or 100 by understanding the face values and the processes of operation.
Excellent. Now that's a lot of words just to remind us that we know how to do this. Okay? We can multiply basic facts. Okay? One single factor multiplied by a multi-digit factor, right? Using different strategies. Okay? Who can read the top sentence? These are 2 of our strategies that we have learned and that we do need to practice some more. Charlotte.
We can use basic facts, patterns, and associated.
Very good. Yes. So basic your desk. And then I want you to follow along. I'm going to do a warm-up together, and then I'm going to let you do some work with your group. All right. I have a bonus question. Who remembers when we're talking about multiplying by multiples of 100 or 1,000, and we see a lot of zeros, what should we do first to help organize our thoughts and to focus on the basic facts? Sahar?
You should just take away the zeros and then multiply the digits that are like not zeros.
Yes, good. Give yourself a tally. Yes, he's right. We're going to underline the digits that are not zero. So in this case, we have 5 and what else? 4. And then, what's my first question? What's my first question after I underline? Savannah?
5 times 4.
Good. What is 5 times 4? Everybody said?
20.
20. So we're going to write 20. Now who knows what we should do? Because sometimes we get a little mixed up since there's already a 0 there. So be careful. Ivy? Very good. Ivy noticed that there's 2 zeros on the factor side of our equation that must be added to that product. And what does that make, friends?
2,000.
2,000. Now, we just used the basic facts and pattern strategy, okay? Multiply the numbers that are not zeros, then add the zeros that are on the factor side. Now, how do we talk about associative property? Let's look. We're going to do the same equation, okay? We're going to write 5 times, and again, you're writing this with me. And now I have another bonus question. How do we decompose or break apart 400? How do we separate the 100 from the 4? And I almost gave it away. Zane?
It's just 400.
Okay. And can you think of a multiplication equation that would use those two numbers to make that, Zane?
5 times 4.
Okay. That was our first one. Keep thinking. How do I make 400 using a multiple of 100?
200 times 2.
Okay, good. But let's use the 4. We're on the right track. We're warming up. Logan.
4 times 100.
There you go. So everybody write 4 times 100. Okay, does this look familiar? This is going all the way back to lesson 6.1.6.2, okay? Now, when we see a multiplication equation with 2 symbols, we can use the associative property, right? And what we're going to do is put parentheses around 5 times 4, because we're associating those numbers, okay? We're grouping them together. When you see parentheses, I don't know if you remember this, but I said it means do this first, okay? So 5 times 4 is what?
20.
20, and then I can just multiply 20 times 100, and we get 20 times 1, and 2 zeros makes 2,000. And you can see that even when we use basic facts and patterns, this is what's really happening, isn't it? When we add 2 zeros, we are multiplying by 10 2 times. And we all know that 10 times 10 is what?
100.
Very good. All right, so now I think you're ready to try this with your group. You're going to focus on with your group on the second equation. Who can read that second equation so we know what we're doing here? Nina.
6 times 5,000.
Excellent. Go ahead. I'm going to give you about 1 minute to work with your group to see if you can solve using one of these 2 strategies. You may begin. Very good. I see this group's already written the equation on their desk. Thank you. When you have come up with your answer, discuss it. Compare it with your group mates.
Where? Yes. How is that? You made me draw 4.
Good, I'm seeing underlines, I'm seeing slashes through zeros. About 10 more seconds.
What did you get?
All right. 1, 2, 3, eyes on me.
1, 2, eyes on you.
Who can raise their hand and tell us what your group discovered and what strategy did you use? Claire?
30,000.
30,000?
Oh no. Yeah.
Oh, okay. And how did you get that?
By decomposing.
Okay, can you tell me what to write and how you decomposed it?
6 times 5 times 1,000.
Oh, wonderful. So they chose to decompose this way and use the associative property. Good. And then which two numbers did you multiply first?
6 times 5.
Which is
30.
30. And then how many zeros did you need to add?
3.
3, because we have 1, 2, 3 on the factor side.
Someone's calling.
And what does that equal?
30,000.
Very good. 30,000. Give me a big thumbs up if your group also got 30,000. Awesome.
Oh.
Okay, good. All right, and one more. Go ahead, erase that, and I think you only need about 25 seconds to try 7 times 2,000. Go ahead with your group. 7 times 2,000. Good. You didn't even need 20 seconds, did you? Okay. Please put your thumbs up if your group has already finished and you already agree on the product. Excellent. Tia, what did your group decide?
14,000.
14,000. And what strategy did you use?
Decompose.
Okay, can you tell me what you wrote?
I wrote 7 times 2 times 1,000.
Wonderful. And then which two numbers did you multiply together first?
7
Which is?
14.
And then 14 times
1,000.
equals?
14,000.
Excellent. Excellent. All right, give me a vote. Do you feel confident about these basic facts with the patterns? Awesome. All right, let's move on. Very good job. I like what I see. All right, next. Our second mission in this unit is listed on the board. Who will read this mission? Nina, please, loud and proud.
I can decompose numbers by digit value and use that to multiply a up to 4-digit whole number by a 1-digit number or by a 2-digit number. You can use an area model and partial products.
Yes, again, a lot of words to represent what we've been doing with more digits. Okay, so let's take a look how we can accomplish this. Okay, we remember these, don't we?
Yes.
All right, so again, we talked about using an area model with partial products, correct? All right, and that's what we're going to warm up and do. All right, my first equation is 3 times 943. So here's what I'd like you to do. You're either going to draw your own area model, or can Cecilia, if you hold up the template for your friends to remind them, or you may use your template. So go ahead and choose which tool you're going to use, and let's do one together before we work on another group challenge. Here we go. I'm going to draw my area model. Now, the area model that we're using would be the top. It would be at the top of your paper because we only have one factor on the left, don't we? So we can make this a 3. And if we have a number in the hundreds, we can break that apart into 3 groups. Again, it's not to scale, but just to separate the equation. And who can tell us how we're going to decompose 943 on an area model? What should I write above the 3 boxes? Nina?
900 in the first box.
Okay, 900.
Then 40 in the next box.
Here's a bonus question. What does this remind us of from place value? Who remembers? Zane? What is breaking apart this number by, I don't want to say it, I'm going to give it away. We're breaking it apart by something that reminds us of a kind of form. Maylee? Expanded form, correct. Okay, now who can tell us our first equation? Once we decompose this, so it looks like expanded form. Sahar? 3 times 900. And guess what? We can just do what we did before. Multiply the digits that are not 0. What is 3 times 9, friends? Everybody said?
27.
And we have just 2 zeros in this equation that we can add to the end. And what does that make?
2,700.
Very good. Mason, can you please tell us the second equation?
40 times 3.
Very good. So we're going to do 40 times 3. 4 times 3 is what?
12.
And how many zeros do we have in this equation?
1.
And that makes?
120.
And our last equation is our favorite, right? 3 times 3 is?
9.
All right. Good. Now, please raise your hand. Tell us the last step. We've already filled in our area model. We already did our partial product equations. What's next? Charlotte?
Add
All of the partial products? The boxes? Yes. So go ahead and set that up, friends. I want to see you set that up as an addition equation. And we're lining up all of our place values. And you take a moment and do that, and then see if your answer matches mine, your sum. And how'd you do? Thumbs up if you got the same answer. 2,829. Did you get that? Awesome. Okay, so now I want you to work in your group. Now we had 3 boxes to represent a number that's in the hundreds. All that you're going to do now is use your entire template on the top and do a number that's in the thousands with 4 digits times 9. Okay, so I'm going to give your group about a minute and a half or less to complete the second equation. You may begin. And you can discuss, especially if you're not discussing now, please be sure to discuss once you found your answer and compare. Good, I see some friends. This one's a little tricky because we don't have any 10s, do we?
Yeah.
So we don't need to add that to our area model because we're just thinking of expanded form. All right, good. I see that we're mostly finished. Let me give you one question to think about as you're finishing up. When we write expanded form, do we write +0 when we do expanded form, Elliot? No. So if you don't write it in expanded form, do we need to write it above our area model? No. Okay. I'm going to go ahead and pause this here because if we're done, good, but many of us are still working and I don't want us to be confused. So, if you're using the first area model, this time we need 4 boxes, right? And did you put a 9 on this side?
Yes.
The single factor side. Then who can tell me how they decomposed 4,503? Thinking about what we know about expanded form. Henry?
First box is 4,000.
Okay.
The second box is 500.
Great.
The third box is a 0 because there's no tens.
Okay, and do we have to put that though? There's 0 tens? Okay. And what would be our next one?
3.
How many ones do we have? 3. Okay. Good. Now my first equation is 9 times 4,000. Who can raise their hand and tell me the product that you got when you solved that? Elliot.
40,518.
Oh, just for 9 times 4,000? What about for 9 times 4,000?
36,000.
Okay, because 9 times 4 is 36. Add those 3 zeros. Good. What about 9 times 500? Who can share their product with me for that equation? Sahar?
4,500.
So you have 9 times 5 is 45 with 2 zeros. Good. And we have 9 times 3 is, everybody said?
27.
27. Very good. Okay? And what would be our final step? Logan.
Add them all up.
Okay. And did somebody get the final product after you added all of the partial products? Who knows the final answer? Nina?
40,527.
Very good. Very good. Now, thumbs up if you got that correct. Your group got that correct. Good. If you got that answer, please put a tally on your desk. And I'm going to erase what we did here because for this one, we need our 4-box template. All right? So everybody go ahead and either draw or find your 4-box template for our 2 by 2 digit area model. All right? Now, is this group willing to help me out? What do we do first? When we look at 68 times 27, that's a lot of digits. Okay? What do we do first? How do we break it apart? Savannah?
So you put the 60 on the corner, like the top corner.
Okay.
Then you put the 8 beside it.
All right, because we are thinking about expanded form. And we know 6 tens is 60, 8 ones. Good. And what should we put on the left-hand side? Savannah?
The 20, and then you have 7 on the bottom.
20 plus 7 makes 27. All right, does that look familiar? Make sure you have your model set up. All right, now who would like to share our first equation? What should we do first? What do we do with these area model boxes? Logan?
You do 20 times 6.
20 times
60.
60. Okay. And we can do that by thinking about what 2 digits first.
2 times 6.
Good. So 2 times 6 is what, friend?
12.
And Logan, how many zeros do I need to add? 2. Good, because we have 1 in the 20 and 1 in the 60. And that makes 1,200. Who can tell me my next equation? I think you're warming up now. Kenzie?
20 times 8.
Okay. And we think 2 times 8 is?
16.
And Kenzie, how many zeros do we have in this equation?
1.
Very good. All right. We have 2 more to go. Who knows the third equation in this area model? Sahar?
7 times 6.
7, we think 7 times 6, which is what? Oh no.
42.
42. And Sahar, how many zeros?
1.
1. And our last one is 7 times what? 8, which is?
56.
Okay. Now, as you can see, if you are prone, Henry, to doing mental math or others who I know are very good at it, I do want you to add it up, okay, in vertically, in column addition, because you're going to have some regrouping sometimes, and you don't want to get incorrect. So go ahead and set that up and see if you get what Mrs. B gets. So we have 1,200 plus 160 plus 420 and then 56. So take a look. When you're done, you can look at the board. Who got the right answer? Very good. Who can read our final answer for us? Lauren?
1,836.
1,836. All right, friends. Good. Who can vote and tell me how you feel about multiplying multi-digits using area model and partial products? How do you feel about that? Lindsay, how do you feel about Saharsh? Ivy? Good. All right. So we're moving on to our last objective of this lesson. Our final mission, which we actually talked about last Thursday and a little bit Friday because we had a lot going on with Halloween, right? But who can read our final mission statement? What can we do? Nina.
I can solve two-step real world problems that use addition, subtraction, multiplication, division, and I can write an equation including a variable to show that I'm right.
Good. Remember that word variable? We're going to see that right now. All right. We have a friend, Maya, here, and she's going to help us figure out how we need to tackle these two-step problems. Who will read about Maya? Charlotte, thank you.
Maya bought 3 boxes of muffins. Each box had 8 muffins. She gave 10 muffins to her friends.
Okay. So, the first step, how do we solve in this class? What should we do as we're reading these word problems? Savannah?
You should underline or circle the numbers.
Good. We have 3 boxes of muffins. Okay. Oh, is this word important?
Yes.
Friends, what does this word mean? Colin? That we should multiply because it's going to be repeated. The same number is being repeated. And we have 8 muffins here. Okay? And look down here, friends. 3 boxes of muffins. Each box had 8. That equation is represented right here. Okay? Then she gave, that means if you give something away, are you losing some or gaining some? Losing. And what operation means that you have to take some away? Subtraction. We can write that symbol to remind us. 10 muffins to her friends. So first, we need to do 3 times 8. And this is where our branches really come in handy. Friends, what is 3 times 8? 24. And now we can bring down the minus 10. And I have a question. Bonus question. Raise your hand. What does the M stand for? Why on earth would they put an M there? Please raise your hand. Claire. M is for muffins, right? So, what is the M called in math language that we just saw on the previous screen? And M is also a what? Ivy? Good. Give yourself a tally. A variable. Okay? Just what it's standing for. What we're looking for is muffins. So 24 take away 10 is what, friends?
14.
14 muffins. Okay, another way to write this is M equals 14. That means muffins equals 14. 14 muffins. Good job. Now, the last challenge before I give you some independent work is another two-step problem that your group will work on.
Yay.
Let's read it together first before you begin. And there is help on the bottom. Okay, this is a reminder, a review. Who will read about this bakery? It's going to make us very hungry, though. I do warn you. Logan?
A bakery sells 47 cupcakes each day for 6 days. On the 7th day, they sell about 120 cupcakes. About how many cupcakes do they sell in a week?
Is anybody's head beeping? Because you saw a very important word in the question. What was it saying to you, Claire? All right, so you saw one for multiply. Was there another word? Sahar? About. What does about mean that we have to do, Sahar? We have to round and estimate, don't we? So, this one gave you a little bit of help. We have 47 cupcakes each day for 6 days. But it says about. Friends, what did they round 47 to? Everybody said?
50.
Right? For rounding to nearest the greatest place value, we have a 4 with a 7 next door. 5 or more, add 1 more. Then we can multiply that by the days, can't we? Okay? And then we can add the 7th day. Now look what they did here. How many cupcakes do they sell in a week? We have to know how many days are in 1 week. Anybody know? So hard? 7. So that means we are taking all of these numbers to get our final answer. Go ahead and see if you can solve this equation, this 2-step equation with your group. I'm going to give you another minute. And what do we know about word problems? Make sure you put your label in them, right? Jared, did you guys start? Good. Very good. So how did you get the 3 units? What did you do first? Good. And then you have the center X. Good, I'm seeing branches. I'm seeing strategies. Good, I did warn you this was going to make us hungry. All right, 1, 2, 3, eyes on me.
1, 2, eyes on you.
Who can raise their hand? Mason, please join us. Who can raise their hand and tell us what your group discovered and what you had to do first? Nina.
I did 50 times 6, but I did 5 times 6, and then I added a 0.
So basically you did 5 times 6 times 10. We're thinking about that. And what did you get?
I got 300.
300. Okay. And then what did you do? Nina?
I did plus 120, then I did 300 plus 120 equals 420.
Excellent. And what very special word do we need on the end of our equation because it is a word problem? Ivy? Cupcakes. Very good. That's a lot of cupcakes, isn't it? A lot of cupcakes. But that's for 1 week, so it's not so bad. All right. Any final questions about any of our 3 objectives in this unit? All right. Here's what I need you to do. The last step is for you to put your marker away and trade it for your pencil. We're going to turn to page 199 in our Volume 1 book. 199. And look at some very special vocabulary together before you begin your review. I've also put your page on the screen. Now, before we begin, I just want to review these very important vocabulary words that we've been using throughout this lesson, throughout our entire unit. And I want to hear from you about these words. Who will read the first one? Savannah.
Writing 4 times 10 plus 8 as 4 times 10 plus 4 has 8 so
Okay, yes. Now that is number 1. Good. But what is the first vocabulary word at the top of the page? Want to try again, Savannah?
area model.
Area model. Who can describe in their own words what an area model is? Lindsay, is that your hand?
Area model is when you take a square or rectangle, you split it up,
you add the numbers and you figure out the product or whatever, or maybe the sum or something like that.
All right, so you split the numbers up, and what are you doing to find each number in each individual box?
So you take, so let's say your sum is like 400. You see, let's say 9. You have to take away 0, so it's easier. So it's basically like a coordinates thing.
Yes, and what operation are we using? You are correct.
Multiplication.
Good. Nina, please have a seat. Good job. Yes, very good. All right, the next one is decompose. Give yourself a tally, Lindsay. Who can tell us in your own words, what do you think about when you hear the word decompose? Logan.
You're breaking apart a number into
Good.
separate parts.
Good. You're breaking it apart into separate parts. Give yourself a tally. Yes. And when we decompose, we do it in a way that's going to what? Pull the tens, hundreds, the easier numbers away, right? Which is essentially expanded form. Good. Distributive property. Distributive property. What do you think about when you hear that? Henry.
I think about the word decompose in expanded form.
Okay? Yeah. Do you have to decompose when you distribute?
Yes.
Yeah, of course. And I think already you're already thinking about one of the answers that word would fit in on this page. When we break apart, okay, the numbers. And then we have factor. Now that's going back even to the last unit. What in the world is a factor? Claire.
A number.
A number that you do what with?
Add.
All right, keep thinking.
Add.
Keep thinking. Savannah?
It's a multiple or product.
Oh, keep thinking. It's a factor, but it is related to that in a way. But what is a factor? Sahar?
A factor is a number that creates a product.
Yes, I heard it first. He said a number that you multiply, right? That creates a product. Correct. So a factor times a factor equals a product or a multiple. Do you remember that little diagram we made together? Good. And we just talked about partial products, and a variable. Okay? So here's what I would like you to do. Just on this page only, go ahead and work with your group and fill out the correct vocabulary term for this page. And then we'll begin our independent work. So go ahead, I'm going to give you about 2.5 minutes to solve this side with your group. You may begin.
I think the first one's the distribution property because it's
as 4 times 10 plus application of the blank. So application shows what we're doing.
this one for me is partial object
Good. I see some of us using process of elimination. Good. Yes. Right, because you see how they're breaking it apart, don't you? Just need to understand that, and that is Right, now who will read number 2 together? Do you want to read number 3?
I think the fourth one's on first series because
It's available. Number 5 is
oh yeah. I get my number 6. Number 5 is the first product.
Okay, so you already said it. So what do you do? Just say blank. Were your groups already done? Wonderful. I see this group's done. Good. And again, you're just working as best as you can until time runs out, and then we'll discuss. Now, you're going to see a lot of synonyms, aren't you, for things we've already learned. Now, I'm going to sit right here so we can record our answers correctly and, again, review our vocabulary. All right, so which group can read number 1 and tell us what you discovered? Zane.
Writing 4 times 10 plus 8 adds 4 times 10 plus 4 times 8 shows
Application.
application of the distributive property.
Very good. Did everybody put distributive properties? If you did, give yourself a big check. If not, just change it and then give yourself a check mark. Right, what are they doing? They're decomposing, and then they know that the factor 4, Nina, has to take a turn with the 10 and has to be multiplied by the 8. Very good. How about number 2? Who will read number 2? Kenzie.
In the expression 7 times 9, the number 7 is a factor.
Good job. Yes, it is a factor. Why? Because it is being multiplied, right? And it will equal a product. It's a number that's being multiplied. Very good. Number 3. Charlotte.
Area model.
Can we read it with the whole phrase?
A and may be used to find partial product.
Yeah, an area model. Very good. May be used, right? It's not mandatory all the time, but it may. It's a great strategy to find partial products. And number 4, Tia?
In the equation C equals 32 times 16, C is a variable.
Very good. C is a variable. It's a letter that stands for something you're trying to find. All right, we'll try number 5. Mason?
The
Partition.
partition areas inside an area model represent a partial product.
Very good. Now, do you see how they use that confusing word? But it didn't confuse many of you, which is awesome, because they're talking about when you have an area model, these spaces right here, inside the boxes. And that is where the partial products go. We know that partition is another word for what? Breaking it apart. Remember we made our arrays and we separated it and we made 2 smaller equations by breaking apart the array? Good. How about number 6 as we're finishing up here? Logan?
To decompose 36 by this value means to write as 20 plus 6.
Very good. And again, give yourself a check mark. And the last one. Nina?
Given 32 times 46 equals 1,472, the number 1,472 is the product.
Is the product. Excellent work, friends. Excellent work. All right, if you would, please turn over your page, and now you're going to get your independent task. On page 200, you're going to see numbers 8 through 16. 8 through 16. Okay, so you may begin working. This is independent work. We're going to be working on page 200 independently as I come around and help as needed. Okay, so we're going to use all of these strategies that we just talked about. Okay, we're going to use partial products, area models, basic facts and patterns to solve the question. All right, great job. Do your best. I know you will. I'll be coming around to help you as needed. You may begin. Yes, and friends, you guys may use your template, of course. Use all of your tools to help you solve the problem. Good job working quietly.